this video, we will see how to construct a loop in ARMv7 assembly using the GNU assembler. So these lines are my skeleton code. I need these other than this label, but I need these other things to have my program run under GNU assembler as a standalone program. So let's look at our standard loop. This is a C loop, right, without the main and all that. But this loop will sum the integers from 1 to 5. So I start off by initializing some variables. Then I come to my while loop and I ask the question, is I less than 6? And if the answer is yes, I enter the body of the loop, produce these two sums. I'll sum this, and technically it's I equals I plus 1. So they're both sums. Come back up, ask the question again. If it's still true, come down, and repeat the process until it's false. Here's the flow chart that represents that to make it more clear about what's happening. When we follow through and do these two lines, when we're done with this, we go back up. So in assembly terms, we need to either jump or branch back up to the top. But we also need to realize that when this is false, we won't execute these two lines, but instead we will branch past them. And that's how we're going to construct the loop initially. And then we'll see a second way of doing it that's slightly different than this. So to do what I just said, let's create our initial two variables, and we'll do move R1, number 1. This would be like our variable I. Move R2, number 0. Sorry, it's number 0. Then our sum, and then we do a comparison. And we'll compare R1, which is our counting variable I, to 6, because we were saying we want to run 5 times. And if we eventually want to stop, we want to branch over the body of the loop, which means I need to do a branch greater than or equal down to end. Because remember our comparison that we were asking about, we don't see it here because this is just simply doing a comparison. But what we're asking about is saying do while I is less than 6. Nothing about this comparison includes the less than. It's simply a comparison, but based upon what flags are set when we do this comparison, then we can use this particular branch. So if the condition is still that I is less than 6, this won't be executed. It will be evaluated to see if it should be executed, but it won't be executed in the sense that we'll jump down to end. So if we fall through, then we want to update the sum. So that's R2. So we'll do add R2, R2, R1. And so that's equivalent to saying sum equals sum plus I. And then we want to update our counter, add R1, R1, number 1, which is I is equal to I plus 1. And now we're done, we need to go back and test again. So I'm going to branch, and I always want to branch here, but I need to come up to here, but I need something to tie it to. So I need a label, and so I'm going to say branch to loop. And now I'm going to come back up here and put loop as a label. So let's assemble and run that and see what happens. So I'm going to assemble, give the output name will be ex.o, because we can see here that my executable, or excuse me, my source code is ex.s. So I give it that name, and I want to include debugging information, so I put -g. I'm going to link. The output name will be ex, and the input name is ex.o, and run the debugger on this. I'm going to set a breakpoint for start, this label right here. I'm going to tell it to run, and I will see the registers. So the sum should be 15. 1 plus 2 plus 3 plus 4 plus 5 is 15. So let's see what happens as we run. So do our comparison, branch. If we now need to skip the body, but we don't, update the sum to 1, update the counter, update the sum by adding 2, so now we're up to 3. Now the counter is now 5. 5 is less than 6. So we continue through, add 5 to the sum, and we can see now it's finally 15. Update the counter to 6. Branch back to the top. Compare 6 to 6. And 6 is not less than 6. So it does satisfy being greater than or equal. So we skip down to the end. And now we're done. So this is the way that matches what I think is the flow chart. Now it's actually much more common. If you look at disassembled code for loops, you'll see that what will happen often is that here's the body, and we do the comparison down here. And then like in our case for I less than 6, we want to branch, if less than, back up to the top here. But how do we avoid, if we're setting our variables I is equal to 1 and sum is equal to 0, those will be right here. How do we avoid doing this to begin with? Well, we'll have a branch here that will branch to the bottom, and it will be executed once. So the benefit of this way in terms of code executed is this branch executes once. We'll still do this as many times as necessary, but there's not another branch that keeps skipping the body over and over again. So let's see how we write the code for that. So some of this we can keep. And now so once again, we start up here, we initialize these two values, we hit the branch, it says jump immediately down here, and now do the comparison. If the relationship is that R1 is less than 6, we will come up to here, update the sum, the counting variable I as well, come right here, the loop, this actually needs a colon, sorry. We don't execute this because it's just a label. We do the comparison again, come back up and repeat this. And let's see that we get 15 again. Set my breakpoint, run, layout to show the registers. Jumped immediately to the bottom, do the comparison. If the relationship is a less than, when we jump up to loop, where we update the sum now for the first time, update my counter, compare, keep repeating this. Remember, we're wanting to go until the sum is equal to 15. So now my counting variable is 5. 5 is less than 6, so we go up again, add 5 to the sum, where we now have the 15. Update my counter, which is now 6. Compare 6 to 6. It's not true that 6 is less than 6, so now we fall through to the end, and our program is over. So once again, if you were to write some C code and disassemble it, you might see something that looks more similar to this than what I think is the more intuitive version, which is to do the comparison at the top.